Welcome to another session of Circuits and Networks. Today we are going to deal with mesh and node analysis, especially the problems involved with dependent sources. So this particular class we are going to treat as class 4. What happens in dependent sources? You can see in these two examples, there is a dependent voltage source which is 5V0 whose dependency is shown across 2 ohms. Whereas in this problem, there is a voltage dependent current source whose dependency is across 20 ohms. So how do we solve this kind of problems? So let's start with first problem. Calculate the value of voltage, that is Vx, across 20 ohms using node analysis. So we are going to start with the given approach, that is node analysis. For that, I'm taking the circuit as it is, and you can see Vx is nothing but it's a voltage measurement across 20 ohms. In fact, the positive potential it is placed on the upper side, the negative potential is placed on the downward side. Moreover, all the elements, that is 2 amperes current source, 10 ohms 10 ohms resistance, 20 ohms resistance, and voltage dependent current source all are arranged in parallel. So that is why you can see this arrangement is taken in parallel and Vx is placed over here. Now with this 2 amperes source current, it is incoming towards the node Vx. 0.2 Vx is the voltage dependent current source which is going away from the node, and since we are going to be assume it to be at higher potential Vx to be at higher potential, the branch current Vx by 10 and the branch current Vx by 20 will leave this particular node. Then applying KCL at this particular node, we are going to get minus 2 plus Vx by 10 plus Vx by 20 plus 0.2 Vx is equal to 0. Take the variable parameter on one side, constant on another side. So this is how the equation is reframed. With this, I am selecting Vx as outside. This 0.2 can be written as 2 by 10 and 2 by 10 is taken inside the value of Vx. Vx is taken here. So the Vx is taken as 40 by 7 whose value will be 5.714 volts. So this is how we solve the node analysis problem. Especially you have to take care of the LCM in the equations. Then only you are going to get the correct result. So the result what we have obtained, it is right or wrong. Let us examine with mesh analysis. In mesh analysis, generally we take the loop currents in clockwise direction. I1, I2, I3, three loops are there. So three loop currents are taken in clockwise direction. You can have your own notation for selecting the direction of the loop current. For my convenience, I have selected I1, I2, I3 all are in clockwise direction. With this, what happens? Now, according to the given problem, 2 amperes is the source current and I1 is the loop current. Both are flowing in the same direction. Therefore, I1 will change it to 2 amperes. Similarly, observe the I3 value. I3 is equal to 0.2 Vx. Now concentrate on Vx. Vx is nothing but it's a voltage measurement across 20 ohms. So according to Ohm's law, V is equal to IR. 20 is the resistance value and the difference of the current I2, I3 will flow as the branch current in 20 ohms. So Vx will be equivalent to 20 times of I2 minus I3. Just substitute the value of 3 into to get the proper equation in terms of I2 and I3. So 4I2 minus 5I3 is equal to 0. This we have obtained using equation 3 and 2. Now concentrate on loop 2. Now in loop 2, applying KVL, we are going to get 10 I2 minus I1, treating the loop 2 with the dominating loop. Then you have 20 I2 minus I3 equal to 0. With this, you are going to get 30 I2 minus 20 I3 is equal to 20. Now we have equation 4 and 5. Just solve equation 4 and 5, you are going to get the value of I2 which is equal to 1.4285 amperes. I3 is equal to 1.1428 amperes. Now once we obtain the value of currents, that is loop currents, we can easily obtain the branch current which is nothing but I2 minus I3. Why it is I2 minus I3? You can see the upper plate is on the positive plate and the lower plate is on the ground side. So current has to flow from higher potential to lower potential and that is aligned with I2, whereas I3 is flowing opposite to the given Vx direction. So that is why Vx is selected to be 20 times of I2 minus I3. Just substitute the values of I2, I3. we are going to get the value of Vx, which is equal to 5.714 volts. Now this is the same value what we have obtained using node analysis. So that is how we solve the problems using mesh analysis as well as node analysis, especially the problems given with dependent sources. Let us go with another example. We need to calculate the value of current through 8 ohms using node analysis. So as the given approach, we have to calculate the value of current in 8 ohms, then identifying node voltage V1 at this point. Similarly, node voltage V2 at this point. So we have two nodes over here. With this, applying KCL to node 1. So V1 is there here. To this node, how many branches are connected? You have 12 volts in series with 2 ohms, that is one branch. You have 4 ohms, that is another branch. 3 amperes source current, another branch. 8 ohms connected between V and V2, that is another branch. So you have 4 nodes, sorry, you have 4 branches to this particular nodes. So we are going to apply the KCL over here. So it will be V1 minus 12 by 2 plus V1 minus V2 by 8 plus V1 by 4. V1 by 4 is this, and 3 amperes is the outgoing current. With this, I am separating the V1 terms and V2 terms and the constants on right hand side. With this, I am going to get the value of equation for this particular node 1 as 7V1 minus V2 is equal to 24. Let us take this value as equation 1. Now applying KCL at node 2. At node 2 we have 3 branches, 3 amperes, 8 ohms and 1 in series with 5 V0. So we are going to apply KCL at this particular node V2. So we are going to get V2 plus 5 V0 by 1, V2 minus V1 by 8 and minus 3 is equal to 0. With this, we can read the equation to be the second one. Once we are done with second equation, we need to find out what is V0. What is V0? V0 is a voltage measured across 2 ohms. So according to Ohm's law, V is equal to IR. So 2 times I0 will be the value of V0. Therefore, I0 will be nothing but it is the difference of the voltages of given source voltage and the voltage at this particular node. So by careful observation, you can see I0 is equal to 12 minus V1 by 2. In fact, V0 by 2. Therefore, V0 will be equivalent to 12 minus V1. I hope you understood this approach. You have I0 is equal to 12 minus V1 by 2. 12 minus V1 is nothing but V0. If at all you select the direction of current opposite to this arrow, then it will be V1 minus 12 by 2. Therefore, V0 will be equivalent to minus of 12 minus V1. So you can go to this approach also or the approach which we have already suggested over here. I think this will give you the correct analysis. So V0 will be equivalent to 12 minus V1. Treat as equation 3. Now substitute this value, that is equation 3 in equation 2. We are going to get V2 plus 60. How you got 60? You have 5 V0. So 5 times 12 will be 60. Minus V1 multiplied with 5 will become minus 5 V1 plus V2 by 8 minus V1 by 8 is equal to 3. So rearrange the terms in terms of V1 and V2. So we are going to get 41 V1 minus 9 V2, it is equal to 456. Now this is another equation what we got here. Already know that we have 7 V1 minus V2 is equal to 24. Now just simplify equation 1 and equation 4 with the help of calculator. We are going to get V1 value which is equal to minus 10.9 volts. V2 is equal to minus 100.36 volts. Now what we need to calculate? We need to calculate the value of current in 8 ohms. Now that will be equivalent to V1 minus V2 by 8. So V1 minus V2 by 8 will give you the value as minus 10.9 plus 100.36 divided by 8, which will be equivalent to 11.18 amperes. So this is a simplified value of the current, which is the branch current obtained across 8 ohms. using node analysis. Now let us solve the problem using mesh analysis. When I go for mesh analysis, I generally take the loop current directions in clockwise. You can have your own direction of currents. Then apply KVL to loop 1. You have minus 12 plus 2i1 plus 4i1 minus i2 equal to 0. With this, you are going to get 6i1 minus 4i2 is equal to 12. Treat as equation 1. Then observe we have 3 amperes. That is the current source shared by two loops. Therefore, it becomes a super mesh. Now with this, you can get the equation for super mesh as I2 because the value of direction I2, it is aligned with 3 amperes. Observe the direction of I2 and 3 amperes both are in same direction, whereas loop current I3 is opposite to 3 amperes. So here you can see I2 minus I3 is equal to 3. I have selected one super mesh equation. Now select the rest of the parameters which are linked to loop 2 as well as loop 3, that is 4 times I2 minus I1. Then you are done with 8 I3, then 1 I2 minus 5 V0 on the path whatever the voltage value it is getting. I am taking the same as it is. So I am treating this as equation 3. Now the important question is, what is V0? In mesh analysis, V0 is nothing but V0 is equal to 2 times I1. So substitute V0 in equation 3. Then I'm going to get 4i2 minus I1 plus 8i3 plus I2 minus 5 times V0, that is 5 into 2, that is 10 I1. So reframe this equation, we are going to get minus 14 I1 plus 5 I2 plus 8 I3 is equal to 0. So treat this equation as 4. Now solving the equations 1, 2 and 4, we are going to get I1 equal to 11.45, I2 equal to 14.8 and 18 amperes, and I3 is equal to 11.18 amperes. This is the answer what we got using node analysis. So this is how we solve the problems involved with dependent sources. Let us go quickly with another circuit. Here you can see we need to find out the value of IB, which is across 250 ohms using node analysis. So the node analysis will give us to select a node voltage V over this particular node, then applying the KCL over here. So V minus 24 by 250. This is one branch current, which is nothing but opposite to the direction of given IB current, plus V by 50 plus V minus 60 IB by 150. So this will be equal to 0. Treat this one as equation 1. And observe I carefully the value of IB. IB here it is nothing but the branch current, which is the difference of the two voltages. One is the 24 and another is the node voltage V. So 24 minus V by 250 will give you the value of IB. Substitute IB in equation 1. So for easy analysis, I am selecting this parameter alone, that is V minus 60 IB by 50, and substituting the value of IB will give you the value as 50, sorry, V minus 60 times of 24 minus V by 250 whole divided by 150. Only this parameter I have selected, and I have substituted the value of IB, and with the cross multiplication I am going to obtain this value as 250 volt 250 V minus 60 times of 24 minus minus plus 60V by 250 times 150. So this will give you the value as 310V minus 1440 whole divided by 250 into 150. So I am substituting this value over here. So then I am going to get V minus 24 by 50. This is as it is. V by 50. This is as it is. Whereas this value is replaced by 310V minus 1440 by 250 times 150. So this I am treating as equation 3. So once this equation is framed, I am taking variable parameters on one side, constant parameters on another side. So this I am going to get. So I have selected V outside. So 1 by 250, 1 by 50 plus 310 by 250 times 150, which is equal to 24 by 250 plus 1440 by 250 times 150. So I am simplifying this value. 1 by 250 will give you the value as 4 milli So milli can be treated as 10 to the power of minus 3. 1 by 50 will be 0.02. 310 by 250 into 150 will give you the value as 8.26 millivolts. So this value is nothing but 8.26 into 10 to the power of minus 3. 24 by 250 will give you the value as 0.096, and 1440 value divided by 250 times 150 will give you the value as 0.0384. So simplifying this value, I'm going to get the value of V, which is equal to 4.166 volts. Now that is the value of voltage we got. What is current IB? IB is nothing but 24 minus V by 250. So substituting the value of V, I'm going to get the value of current, which is equal to 0.07933 amperes or 79.33 milliamperes. So this is a careful observation what you have to make in order to solve the node analysis when you're dealing with higher values, high power values. So whatever we have done, it is right or wrong. Let us cross examine with mesh analysis. So simply I'm taking the current directions in clockwise I1, I2 and applying KVL to loop 1, which I'm going to get the value as 300 I1 minus 50 I2 is equal to 24. Then I'm going with the loop 2, which will give you the value as 50 I2 minus I1 plus 60 IB plus 150 I2 is equal to 0. Luckily, IB and I1 both the directions are same, so IB I am treating as I1 because the loop current direction and given branch current directions are one and the same. So substituting the value over here, I'm going to get 10 I1 plus 1200 I2 is equal to 0. So with equation 1 and 2, IB, that is I1 value, which will be obtained as 0.07933 amperes or 79.33 milliamperes. This is the same current what we have obtained using node analysis. And you can get the value of I2, which is equal to minus 3.96 milliamperes. So overall conclusion, whether you apply mesh analysis or node analysis, whether it is dependent sources or independent voltage sources or current sources, the value of the magnitude of the parameter which has to be measured or obtained across particular element, it has to be always the same. So in today's class we have done with dependent sources, especially involved with mesh analysis and node analysis. I hope you like my video. Share among your friends, subscribe to my channel and press the bell icon for the future notifications. Thank you.